Hello, everybody. My name is Suel Pozel, and I'm the Senior Product Manager working on Netfab. And in this presentation, I want to highlight some of the new projects that we are rolling out with the 2021 version of Netfab. So in this presentation, we'll be highlighting some of the release highlights for Netfab 2021, as well as Netfab Simulation 2021. So let's get started. The release itself focuses on three key areas: market impact, user experience, and thought leadership. On the market impact side, we are continuing our efforts in integrating new hardware and improving our connections to existing hardware. On the user experience side, we have some new improvements to the ability to create support structures, improvements in the part library, as well as arranging parts. And we focused on automating some common workflows. On the thought leadership side, we have some new 3D packing technology that's rolled out with this release, as well as improvements to our advanced toolpath utility. And this is all topped off with increasing the limits of what's possible with simulation utility that's included with Netfab Ultimate. So let's get right into it. The first focus area was integrating new machines. And here we worked with three different vendors, Origin, Formlabs, and Mimaki, to integrate some of the new printers that are coming to market. So from Origin, we have Origin 1, which is an SLA printer. From Formlabs, we have two new printers we have onboarded. One is Form 3L, which is a large format SLA, and the Fuse 1, which is an SLS printer. And from Mimaki, we have a UV curable inkjet printer that is full color, that is integrated into Netfab this release. The next improvement is around our connection with HP printers. And here we worked on three key areas. One is focusing on creating custom job settings. Within the context of editing a job setting, the ability to create a print profile and effectively managing it allows for quick print setting customizations per material. And when it's time to send the job to the printer, the ability to view that customization allows for a quick last-minute sanity check just before submitting the job to the printer. In addition, we have also enabled the ability to push the entire build platform to the HP SmartStream 3D Build Manager so that you can print both from the Netfab software as well as the HP SmartStream software. The next improvement is around user experience. And the first thing I want to highlight here is some new support structure functionality. We have three key categories we focused on. The first one is the ability to clone or duplicate support structures between similar parts. In the past, you could always copy a support structure if the parts were exactly the same. And in this release, you can copy and paste them if the parts are close enough. The next one is the ability to create tapered polyline supports. And this allows for minimizing the support footprint and the overall effort required to remove support structures. And finally, the automatically created bar supports can now recognize thin sections of your geometry and create a single path of bars, and it will override some of your global contour offsets settings, and this will ensure that you have full support whenever you are using bar supports, even in thin sections of geometry that do require support structures. Next, we have made some improvements to our part library. Part library allows you to drag and drop common parts that you use to print into your platform. In the past, this was a pre-populated list of parts, and in this release, we are allowing our users to save their commonly printed parts into their own custom library so they can quickly access them. This is often used in filling up build platforms with things like test specimens and or giveaway parts. This next improvement is around arranging parts. In the 2021 version, we have completely redesigned the duplicate parts dialog. With this new duplicate parts dialog, you can now duplicate parts in place. You can duplicate parts to fill an entire platform, or you can create rectangular patterns with ease. Whenever you're dealing with multiple parts in and around the platform, you also need a quick tool to be able to select all the parts based on their platform position. That could be all the parts inside the platform or outside the platform. For example, with this new selection tool, you can select all the parts partially and fully outside the platform and either delete them or move them to a new platform to print easily. In addition to arranging parts, we've also made improvements to our 3D packing methods. We've added two new 3D packing selections. The first one is based on part size, and the second one is based on a gravity-based physics engine. Using the new size sorting method allows users to prioritize large parts to be packed in the center of the platform and fill the rest of the platform volume with smaller objects to improve part quality. Using a physics engine to simulate gravity packs parts more closely, resulting in better pack density. Final improvement in usability was around automating common workflows. We added 3 new improvements in this category. The first one is an entirely new example script that allows you to compare similar meshes. The second one is automating the support separation action. And the third one is the ability to quickly duplicate any workspace. The mesh compare automatically points out differences between two meshes with a color representation and a graph. And the automatic support separation allows you to separate open and solid supports into 2 parts to have better control over objects when assigning toolpath parameters. And now we move over to advanced toolpath utility improvements. We focused on 3 key areas: some new hatch patterns, ability to inspect and run smoke simulations for SLM solutions and Renishaw-based slice data, and the ability to control toolpath vectors based on third-party inputs. Hatch patterns help balance thermal input and improve build quality, and hexagonal hatch patterns will definitely help with that. When we move over to the smoke simulation, we know that smoke buildup in the chamber can cause laser deflection and lead to build quality issues. Smoke simulation helps identify areas where the laser path interferes with the plume, especially for multi-laser systems. And we now have the ability to simulate those for SLM and Renishaw systems. And finally, the controlling of the toolpath vector based on external inputs. Those could come in from either simulation results or other inputs. And the idea here is to use these external inputs to try alternatives for minimizing things like distortion and recorder blade interferences for areas of high distortion. Since we started talking about simulation, it's time to talk a little bit about what happened in the simulation utility with this release. Simulation utility is included with Netfab Ultimate and is used for process simulation for metal powder bed fusion technology. It is, however, limited to a certain number of nodes and elements, but in this release we have increased those limits to solve more and more complex geometries. And using this new limits, you can now identify and remedy common build failures such as distortions, recorder blade interferences, hotspots and lack of fusion zones, as well as support structure failures. Now, moving on to the full Netfab local simulation software, there has been a couple of key improvements in that as well. The first one is the new PRM files that is being shipped with the software. These are for an EOS M290 as well as an Additive Industries Metal-Fab 1, and they are there to simulate printing with Inconel 718 using the machine vendor defaults. And using these new PRM files, you can now achieve more accurate simulation results for default machine settings without needing to generate a PRM file for Inconel 718 if you have those two machines. And when we move over from metal powder bed fusion to directed energy deposition, there has been some improvements on that as well. In the past, we've had the ability to create a compensated shape based on simulation for metal powder bed fusion solutions. And now we've taken that technology and made it available for directed energy deposition simulations as well. So now, whenever you're bringing your toolpath for the robot and simulating that for a directed energy deposition simulation, the software can take that distorted geometry and create a compensated STL for it, and you can create your new toolpath for that, and the outcome will be minimizing the distortion of that DED simulation. Now that you've seen all the improvements in the 2021 version, if you have any questions, feel free to reach out to us. Once again, my name is Sual Pozel, and I'm the product manager. And with me is Lucas Furman, who is the product owner for Netfab product, and Eric Denlinger, and who is the product owner for Netfab Simulation. Thank you for listening, and looking forward to hearing from you soon.